As a label, it's only been around for about 4 or 5 years now. Before that, they were calling it Biochar, and before that, it was just terra preta, the Brazilian term. So, the payoff here at the end is that I'm going to tell you how, of course, it depends, but you could cut your fertilizer costs in half forever and practice a far more sustainable form of agriculture using what people in other parts of the world have known for thousands of years. So, to get to what I mean by that, when you grow, when a tree grows, the tree is standing here in here for any plant. You know that takes carbon dioxide in from the atmosphere. It sequesters some of the carbon in the tree itself. Some of the carbon is in the root, right? It emits O2 that we breathe, right? Now, we as an animal, we inhale the O2, exhale the CO2, and this is gross oversimplification, but the important thing here is that it is a continuous, stable, balanced cycle. When this tree dies, here we have a dead tree on the ground. It can do one of two things. It can die, or it can burn. That's in nature. Those are the two most likely things it can do. It can decompose, or it can burn in a forest fire. Both of these are very similar in that the carbon is released again. When it breaks down, there's little microbes in the soil and on the plant, which then basically exhale CO2 again. And of course, when it burns, it takes oxygen in and spits out CO2 as well. So basically, the carbon is in the atmosphere, or it's in the plant, or it's in the carbon biomass of the soil, which is another issue. But the point is, there's nothing added or removed. It's stable, and it had to be stable. Otherwise, we'd have had runaway levels of carbon in the atmosphere or soil thousands of feet thick. We'd have one or the other from the millennia that nature's been doing this. We don't, because this is a nice cycle. So, where humans go and mess it up, of course, is we take all these hydrocarbons out of the ground. They've been in there a long, long time. Here's a hydrocarbon. It's got little hydrogens coming off of it. Some of them are in rings, six-sided rings, etc. We take them up out of the ground and we burn them. I burned a fair number of them just to come here today and talk to you about this, making me somewhat critical. But those darn humans burn them. And in so doing, we're taking carbon up out of the ground and burning it up into the atmosphere, putting CO2 up there. That hasn't been up there for hundreds of millions of years. This obviously has bad effects that went beyond the scope of our talk today. But the good news is there is a way out of this mess. And that is, if you take your tree and instead of letting it simply decompose or burning it, burning it is not that bad. If you grow a tree and you burn it, and you get your energy and you warm your house or you generate your electricity, you are at least still carbon negative, carbon neutral, I should point out. You're neither adding nor removing carbon. The same carbon that was sucked out of the atmosphere when the tree grew is then released back again. The picture is slightly more complex because burning can be messy and there's other things besides CO2 and water vapor. But in the big picture of carbon, it is carbon neutral. It's not that bad, but there is something better you can do. You can take your tree and make charcoal. Now, you are left basically with pure carbon. Pure carbon. And how you do this is you heat wood without the presence of air. Heat it in a closed chamber, heat it in an emu, heat it in a pit, heat it anywhere where air cannot get to it. And what you end up with is something a lot like this. These are chunks of charcoal from my own charcoal kiln. It's actually a retort, not a kiln, but yes, charcoal oven, to use that less technical term. You can char anything, whether it's little tiny branches like this. This was actually a piece of wood that was about yay big around. It went into my kiln and became, and then it just breaks apart. Pieces like this. Yeah?
What kind?
In this particular one, I happen to be using Eucalyptus robusta and cypress branches for the most part. That's why I got a lot of it in my part of the land. You could use Vibe. In fact, it's an excellent use for all the Vibe on the island. I believe here in Kona you have some issues with Christmas berry. There's plenty of things. We have no shortage of wood that needs something done with it on this island. One of the criticisms that people have put forward as a potential problem with large-scale use of making a charcoal on this planet is that you start to dig into native forests. Or worse, you chop down a native forest, you make a tree plantation, just so you have a source of charcoal. And the answer, of course, to this is don't do that. There are so many other sources of waste biomass that they're low-hanging fruit. And these things are huge. I mean, on this island, there are things like magnet shells. I mean, there are, before you even pick up a chainsaw to your first Vibe tree, you've already got a lot of other waste biomass lying around. That makes really, magnet shells makes really excellent charcoal, which is why they're building a $20 million plant in Kauai right now to do exactly that. But that's not agricultural. So here it is in chunks. What I do is I push it through a half-inch screen, and I get this stuff. It's in little half-inch pieces. And this is plain broken up charcoal. Charcoal has its amazing properties. Carbon, we're just even discovering just in the past 10 years amazing things that forms of carbon can do. Buckminster fullerenes, carbon nanotubes, graphite properties. All this stuff that science has discovered about carbon just recently. Oh yes, and your fingers will get black if you don't wear gloves.
I think there's a faucet in there, it's sick.
Ah, well, it's okay, it's healthy. You don't want to breathe large amounts of any dust, but it is relatively healthy stuff. It's neutral. Carbon in the charcoal form is basically an amazing sponge or filter. That's the reason why they use it in water filtration. You got a piece of a charcoal filter, whatever. The water goes through it, the impurities stick into the charcoal. It's got incredible surface area. It's got millions and billions of little nooks and crannies in it, and these provide little bonding spots for nutrients. So, the most easily explained benefit of this agriculturally is if you have charcoal in your soil and you lay your fertilizer on top of the ground, whether it's organic, inorganic, or whatever, the rains come, a certain amount is going to be lost through leaching, and a certain amount is going to volatilize to the atmosphere. And if it sticks around long enough, then the plant can get to it. You can greatly increase the amount of time it's going to stay around by having a charcoal in your soil. That's gross oversimplification of a very large, complex scientific subject, but that's basically how it works. The other benefits are these things have an amazing interaction with mycorrhizae. This is just papers from 2 years ago where they saw my first electron tunneling microscope picture of a mycorrhizae going into a piece of charcoal and just having a great time, moving through all the little pores and whatever. It's basically like a condominium for microbes. Whether you are a kind of person like BIZEM or whatever like that, you're leveraging the power of boosting microbe populations in your soil, this automatically boosts microbe population because it gives them a nice, cozy place to live.